Assalamualaikum warahmatullahi wabarakatuh. My name is Nasrul Arsyad bin Abdul Majid, a final year student of MEC 300. My final year project title is Effect of Cooling Ash as Partial Replacement for Bentonite in Green Cement on Mold Strength and Aluminum Casting Quality. This project is supervised under Dr. Muhammad FAIZUL IDHAM bin Muhammad ZULKIPLI. This research explored the potential of QURANIC ash as a suitable alternative to bentonite in traditional green sand casting. The study aims to evaluate how this substitution influences the mechanical strength of the mold and the overall quality of aluminum casting. This presentation is organized into several key sections. It starts with an introduction to the topic, followed by a clear problem statement and the main objective of the study. The scope of work outlines what the project covers, while the methodology explains how the research was carried out. Result and discussion present the finding and their meaning. The conclusion summarize the outcome and the significant study highlight why the research method. For introduction, this study looks at how QURANIC ash can be used to replace some bentonite in green sand mold. First, it will investigate the effect of QURANIC ash as a partial replacement for bentonite in green sand mold. Second, it will determine the impact of QURANIC ash on mold properties. Third, assess aluminum casting quality when using green sand mold with QURANIC ash. And lastly, explore QURANIC ash as a cost-effective alternative to bentonite. For the problem statement, bentonite has long been the backbone of green sand molding, prized for its strength and reliability, but it's come at a cost. Mining bentonite is expensive, time-consuming, and harmful to the environment. What if we could replace part of it with something more sustainable? This project explored the use of QURANIC ash, a natural and meaningful alternative to reduce mining impact and cut costs while maintaining casting quality. It's not just a technical shift, it's a step toward greener, more responsible manufacturing. Objective for this project is divided by two. First, to analyze the effect of QURANIC ash as a potential replacement for the green sand mold properties by reducing the bentonite. Second, to investigate the properties of aluminum pouring on the mold of green sand casting with QURANIC ash. Scope of work for this project has four elements. First is aluminum. Aluminum is main casting material used to evaluate the mold performance. Second is QURANIC ash, alternative binder tested to replace part of bentonite in green sand. Third is green sand component. Mixture includes sand, water, bentonite, and QURANIC ash. And lastly is hardness, measured to assess mold strength and casting surface quality. In this slide, I will talk about the methodology for this project. This experiment follows a step-by-step process to test QURANIC ash in aluminum casting. First, silica sand and QURANIC ash are sieved to get the right grain size. Then, green sand mold are made for 5 parameters, and the 5 parameters are tested for mold strength. Sample for the original mold and the selected mold based of it near the strength of the original are heated to check fusion point. After casting with the selected green sand mold, the aluminum surface is polished, cut and molded for analysis. Finally, hardness and microstructure are checked to see how well the mold perform. For result and discussion, first I will talk about grain fineness number, GFN. Silica sand has most of its grains in the middle range sieve 50 to 70. This gives is a grain fineness number of 62.25, meaning it is medium coarse and good for airflow and smooth cutting surface. QURANIC ash is much coarser with 52% of its grain in the 20 and 30 sieve and only 2% very fine. Its GFN is lower at 31.86, which allows better gas release but can make the casting surface rough. In short, silica sand is more balanced while QURANIC ash has larger grains that change how the mold works. For the sand strength, The graph displays sandstone between standard greenstone mold and greenstone mold containing QURANIC ash as additive. B0 and mixed greenstone clearly demonstrate the most robust performance, with strength values that climb steadily to a peak during the final test phase, pointing to superbonding coherence. The B4 mixture yield the best result among the modified sample. While it trades the pure sand, the B4 mix maintains stability. In summary, the B4 level offers a functional balance within the tested group and will be used in the experiment to test aluminum properties. The fusion point test shows how much weight B4 and B0 lose when heated. Both start at 20 grams at room temperature. As the temperature rises to 900 Celsius, their weight slowly drops. B4 ends at 17.69 grams and B0 ends at 17.66 grams. This means both materials react similarly to heat, but B4 keeps slightly more weight, showing it may be a bit more stable at high temperature. For the FTIR test, show different P that represent the chemical bond in QURANIC ash. The height peaks around 3,860 to 3,450 show water or hydroxyl compound. Peaks near 2,980 to 2,870 point to bond from organic matter. The strong signal at 1,797 show carbonic group, while 1,635 suggests double bond of amides. Around 1,456 bending vibration of the methyl group or carbon oxygen appear. The peak at 1,014, 874 and 712 confirm silicate mineral, and the lower band near 670 to 466 show metal oxide or silicate mineral bond. This peak proof QURANIC ash contains hydroxyl carbonate and silicate group that help it bond well in green sand mold. Hardness test for aluminum. The above graph shows that the hardness test for the sample B4 has a higher hardness value than B0. B4 reached just below 120, while B0 is slightly above 100. This means B4 molds are stronger and more durable, which can help improve casting quality and reduce defect. The microstructure analysis showed that B4 has a tighter needle-like shape, while B0 looks more spread out. This means B4 has stronger bonding and better mold strength, while B0 is weaker. The denser structure in B4 also supports smoother casting result, making it more reliable compared to the looser arrangement seen in B0. These findings indicate that the inclusion of QURANIC ash in B4 not only improves mechanical properties, but also enhance the internal structure of the mold, making it a promising alternative to traditional bentonite-based mixture. Conclusion for this project is this study showed that QURANIC ash can be used as a replacement for bentonite in green sand mold for aluminum casting. The best balance between mold strength and stability. Dry finance number results indicate improved permeability, while fusion point testing confirmed that the mold can withstand aluminum pouring temperature. Aluminum cast using QURANIC ash mold exhibit finer microstructure and higher hardness compared to conventional molds. Overall, QURANIC ash is a viable, eco-friendly, and cost-effective alternative to partially replace bentonite in green sand casting application. Significant study for this project, we can get 3 sustainable development goals. First, climate action, goal number 13. This project helped reduce environmental impact by using QURANIC ash instead of pouring bentonite. Second is responsible consumption and production, goal number 12. It promotes the use of waste material in casting to support sustainable practice. And lastly, industry, innovation, and infrastructure. Goal number 9. The study introduced a new eco-friendly method to improve casting in the manufacturing industry. That's all presentation from me. Thank you very much for watching until the end.